life and has not suffered any changes by the way of appearance and organoleptic properties like a color, odor, taste, such things. Hardness, that is whether it is a flexible or a smooth or brittle like that. Brittleness means it should not be getting chipping like that. And the particle size, it should never become bigger or smaller. So these are all the changes which can be predicted. What is that? Appearance, organoleptic properties. So appearing, it is a free-flowing liquid, solid. Like that we have that appearance. And organoleptic properties, pale yellow color, white color, cream color, brown color, with characteristic pungent odor, or it is maybe a lemon taste, or strawberry flavor with pink in color, with strawberry taste. Such things will be present in the shapes, anything. They should be persistently present. And the hardness, it should not become too hard and it should not become too brittle. Brittleness, it should not be getting chipped and broken into the pieces. And particle size. These are all the parameters we need to consider to see the physical stability is concerned. It is significant as it affects pharmaceutical elegance. For seeing by the patient, he thinks that he has got another formulation received, even though it is used by him is the same brand, but because there is a change in the color, odor, taste, everything, he thinks that I am getting different thing. Because it will be having a elegance has gone, and drug content uniformity will be getting affected because there is a change in the particle size. That will be having a drug content will be varied from the bottom to the top. Dissolution rate, obviously it will be getting affected because the bigger particle will be having a least surface area and there will be less soluble when compared to smaller one which is having a highest surface area, and they will be fast dissolving. So these are all the factors that affect. That is the reason we are going to give one test is called as a description in every stability studies. So that will give the account of physical stability into the consideration. Just we watch by the visual eye and we will be informing in the description whatever its conditions. The major likely physical instability problems are loss of flavor. So it is having a foul smelling and nobody will prefer to take it because they get the vomiting like sensation, nauseating, and change in the taste, it will be altering. The original taste will be getting altered. Presence of off flavors due to the interaction with the plastic bottle, and previously when the flavor is added it is optimum. But it will not be having any flavor now because it is got absorbed because of the stability problem. Loss of the dye, the dosage form will become a pale, sometimes it will become a colorless. Precipitation and precipitation of the color or any excipient, or discoloration, it is becoming particular places where it is having a low colored pieces, or it is having a regions where it is having a low colors. So the change in the smell or the feel or the taste, which will be having an effect, which we see that as there is something is going on with the bottle. So when we are selling them, the patient may feel unhappy by seeing that, and we should not allow this to happen, and we need to rectify that. Because of this reason, even though it is having a physical instability problem, may not be affecting its efficacy. It will treat the disease, but we should not allow that package entering into the market. So we need to test what is going on there and act against it by changing the package, by changing the color, or changing any excipient. And by doing any modification in the process, we are going to enhance physical stability. Most of the times in the parenteral solution, where we need to take the liquid into the syringe and inject it into the body in the muscular route or intravenous route. Discoloration due to the photochemical reaction or the oxidation that may be causing a damage to the product because of the chemical nature is getting altered. The presence of the precipitate due to the interaction with the container or the stopper that will block the syringe when we are going to take into the syringe for the injection into the patient. So the presence of viscous and cloudy appearance due to chemical changes, and the original preparation of the supersaturated solution may be getting precipitated that causes the change in the appearance and in the bioavailability. And most of the times we put in the label that whatever the foreign particle is present, which is not present initially, you need to throw it, and we should not use consult your physician. That is the one which you are going to give as a label to avoid such problems. In the suspensions, most of the problem we have already seen in the previous first sessional portion is settling very fast, caking, and it is very tough to redisperse, and crystal growth. The particles are becoming bigger and bigger. So what will happen? You are going to have a loss of drug content uniformity because they are having a hard cake and they are getting very settling, and different doses from the different bottle will have a different amount of drug. The second is the loss of elegance is the biggest problem in that, and we are going to encounter that. For that only we have got a different concept like a deflocculated and flocculated suspensions, and making it same in initial and final in the similar one, whether it is flocculated, initial also flocculated, later onwards also flocculated, and it should not change. Another one which is going to be getting affected physically, preferably most of the times, is emulsion. It is more prone to get degraded. And the major problem is coalescence and the creaming, and the complete layer is getting separated, and all the globules are becoming adhered to each other and settling as one layer. Most of the times, the loss of the drug content with uniformity different doses is the biggest problem. And loss of elegance is another issue, so we need to avoid that. For that only, we are using some viscosity building agents, enhancement of reduction in the surface tension, and making a more wetting. Such concepts we are already going to do it, and we are preventing the agglomeration of the particles, and by keeping in the constant temperatures, that will also make the difference. So most of the times, why it is considered, we have already seen in the first sessional portion syllabus, the good emulsion, it will be having polydisperse systems. They will be throughoutly distributed in the uniform manner. And the worst condition is, the fourth condition is the breaking. That is actually ultimately separating an oil and water. Whereas in the population, the aggregation is going to be getting happening and making a bigger agglomerate and flocule are present. And in the coalescence, all these floccules are getting merged to become a bigger globule, and they tend to become a breaking and creaming later onwards. In the creaming, because of the density differences, they will be either settling or going down depending upon the oil in or water in emulsion. In the oil in water emulsion, they tend to float. In water in oil emulsion, they tend to settle in the creaming. Semi-solid dosage form like ointments and suppositories, they will be having a problem. Obviously, the changes in the particle size and the consistency. Most of the times, what will happen? We are going to dissolve the solid in the case of ointments, in the ointment base like oleaginous basis, or it may be a water-soluble basis or water absorption basis, or dispersed as a suspending as a solid. So the solid will be intact. When the particle growth is present, the ointment or cream will become gritty. It will be having a abrasive in nature, and nobody will prefer to use that. So that is the reason which we are going to have the problem. And caking and their coalescence in the case of semi-solids which are made by the emulsion technology is going to be taking place. And bleeding, most of the times it is in the case of suppositories, it will tend to be happened. And because of these reasons, we are going to have a loss of content uniformity, loss of elegance, and changing the drug release rates will be present. Most of the times, it should be avoided. Another one is the tablet. This tablet is concerned when the stability, they will be affecting its disintegration time and dissolution profile. Most of the times, what is the disintegration is breaking up a tablet into a granule and small pieces. That is called as the tablet is converted into a granule. That is called as a disintegration. How much time it is taking? If it is delayed, the tablet will not work properly. So we need to test this one also during our stability. In addition to our changes in the assay of your drug and your content present in the each dose of your dosage form. In addition to that, we are going to do this disintegration also in the case of tablet, because it is very much critical. When it is converted into a granule, it will be dissolving and made into a solution. That is called as a dissolution profile, how fast and how slow it is becoming a solution form. That is also getting affected. And its hardness. It should not be too hard, and it should not be getting too brittle. And appearance. Most of the times, the soft and sticky and ugly appearance and come to becoming very hard, and cracks are appearing onto the surface. That will give an ugly look. So most of these changes, they cause the changes in the drug release. So it will affect the functionality of the dosage form. We need to take this physical concern, physical stability also into the concern whenever we are launching our product. Another one is a capsule. Capsule will be having the appearance, dissolution, and the strength. Most of the times, the strength is depending upon the humidity. So when the humidity is very high, the capsule will become sticky in nature. When the humidity is very low and it will be exposed to the environment, it will become brittle. It will become like a powder. It will, when you are taking it to the palm, it will become powder-like thing. So it will break. So this is actually one problem, and this causes the changes in the release pattern of the drug from the capsule, because it's variation of the capsule shell and its components. It will affect the internal component also. Most of the times, to test this, in addition to our regular bulk drug material, we are having a white solid, and which will be given as an initial material. It is having a clear white free flowing solid, and it should be white free flowing solid also, without any agglomerate during the stability also. Such things we are going to observe. For that purpose, we are going to test. One is a long term, that is also called as a real time stability testing. So the long term testing means we are going to keep the dosage form for the longer period of the time, and we need to test it before launching our product. So the stability evaluation of the physical and chemical and biological and microbiological characteristics of the drug product during the duration of the shelf life, how much we are projecting. Say, for example, we are saying that our product is for 2 years. We need to test for 2 years in the long term. Now, entire 2 years. If it is 5 years, we are going to test entire 5 years continuously in the long term. Keep on going, and we are going to do. But it is not actually possible to do to the entire thing. So regulatory bodies, they assign meeting both for a certain period of the time. They will allow you to enter into the market, and you can do the real-time studies in due course of time and supply to them. Frequently, every annual report, you need to add them as a report. They will allow. Because this is a stability, we have already mentioned, it is legal. It means it is a law. We need to follow without any skip. For that purpose, we are going to study them in the accelerated conditions also. And ICH is the harmonized conditions, which is made by the America, Europe, and Japan. And the entire world accept these guidelines regarding the quality of our products are concerned. So this describes the sampling times and storage condition and specific test parameter for each dosage form individually. And the FDA and the expert working group of the ICH of the technical requirement for the registration of the pharmaceutical or the human consumption in particular country, so which we are going to sell, they will be publishing their guideline for conducting the actual studies. They include, there are 4 types of the guidelines they are given. This is a extension of your learning for your MBA purpose, you can say. Even though it is not present in your syllabus curriculum in the stability, but in GPAT, they will be asking you. Most of the times, what will happen in the stability when you are making the guidelines of your ICH, like guidelines of Q, that is actually a quality, the quality guidelines with respect to safety, and with respect to E, that is efficacy, and M, that is multidisciplinary. So these all batches are guidelines which we are going to consider and use it for our purpose, for selling into the market. This we need to follow. That means quality, safety, efficacy, and multidisciplinary guidelines. In those guidelines, what it has been given, the quality guidelines 1A, B, C, D, E, it is present. In that quality guideline 1A, that is in the group of Q, that is appearing as a quality in the first group. And the group and the entire group of this S is the safety guidelines, E is efficacy, M is the quality guideline multidisciplinary. In the quality guidelines Q1, similarly we have got S1. So we have got in this group we have got E1 and M1. Like that we have got a different guidelines, so they will be numbered. So now in the Q1 guidelines, A is 1A. They are concerned with the stability testing of a new drug substances and the products. 1A. This is GPAT questions. In the ICH guideline 1A is the stability testing of a new drug substances and the products. Whereas 1B is photostability, that is photolysis, what we have studied, that is testing of a new drugs and substances. 1C is stability testing of new dosage forms. Previously, what you have mentioned in the above cases is drugs. Here it is a new dosage forms. So 1D is a bracketing and matricing design for the stability testing of a new drug products and substances. What is this bracketing and matricing? Say, for example, you are selling your product. It's 100 mg, 150 mg, 200 mg, 250 mg, 300 mg, like that 50 increments you are selling your product. Say, for example, you have got 100, 200, 300, 400. 4 dose tablets are present. In the bracketing, what will happen? You can use both lower strength and upper strength and bracket in between 200, 300, you need to test it for the stability. Your extremes, if you are testing them, based on the results, you can enter into the market in between strength also. With the similar excipient combination and formula, you can enter. It means that the bracketing, it will reduce the number of dosage form for testing. Because you are already doing the analysis and you are testing, why do you want to repeat the same thing? And if you are doing the same thing for the smaller doses and the higher doses, intermediate doses, obviously it will be following. Another one is the matricing. In the matricing, what will happen? You will not test all months, for all the dosage form. You will prepare a matrix and you will pick up according to the matrix design, and you will pick up and reduce the number of testing of your products so that your load will be less. And 1E, Q1E, it is applicable for the evaluation of the stability data. This is what it is concerned with the stability guidelines which are present in the ICH guidelines in the group quality Q1A, B, C, D, E. This is actually what you have got a guideline pertaining to the stability. This is a law. It is not a particularly, we need to follow them without any skip. What they are mentioning, we need to follow, and we need to test in their what the guideline they have mentioned. These guidelines provide definitions of the key terms and the principle used in the stability testing and the drug substance and the drug products. Most of the times, the drug substances, you don't think that only it is a drug. It will include your basic components and the preservatives, and we are going to take an excipients. In combination also, we are going to test in the drug compatibility. That will be present. And outlined a combination of the temperature and humidity for the stability studies they have mentioned. So that is frequently followed throughout the world. So one is minus 15 degrees centigrade plus or minus 5 degrees centigrade, 5 degrees centigrade plus or minus 3, 25 degrees centigrade plus or minus 2 with 60% RH, that is relative humidity. Relative humidity, you have got already in the engineering. We have already learned. Relative humidity is actual humidity divided by saturation humidity into 100. So we calculate by either dew point or the psychrometric chart actual humidity. With the similar manner, we are going to do the saturation humidity also, and we calculate the percent RH and bring down our environmental oven to that particular percent RH which is specified by the ICH, and keep our product in that particular temperature in the oven, and keep the humidity of that oven set to that particular 60 RH. If it is present, accordingly we need to saturate the oven, retain the product in that condition in the packaging where we want to sell, and take the sample every periodically and test for it, see the physical and chemical changes, then we consider that it is having a stable. And wherever the period which is having a stability, we consider that as a shelf life. And that shelf life is used as the expiration date period, and we will be putting onto the label expiry date, manufacturing date, and the shelf life, whatever we are going to add it, and we are going to make it as a expiry date. So we are also having a batch number as a concept, we are printing on it. So this is a journey which will be keeping on for every dosage form we are launching into the market. It means our stability is very important, and almost every country will bother about it without any skip. Otherwise, the persons who they are present, the people they are present in their country, they are not having a, they will be having a health problems because of these stability issues. So they will not allow. So there is another frequently used condition is for the accelerated testing is 40 degrees centigrade plus or minus to 75% RH. There are some intermediate conditions also present, that is 30 degrees centigrade plus or minus 2 with 60% RH. This relative humidity will be having a plus or minus limit, that is 5%, like that. It is GPAT questions. Whether it is a 5 or a 10, they will be asking you. For the relative humidity, you are having preferably for the 5% as the plus or minus window. It means you can vary from the 55 to 65%, because you cannot maintain exactly. 75 RH, it can be 70 to 80%, but not less than this 70 and not more than 80. Similarly, plus or minus 2 means it is 40 plus or minus 2 means 38 to 42. It will be allowed, because when you are setting in the oven and it is fluctuating because of any reason, we cannot make it that I am testing has gone bad because it is reduced to 39.5. They have allowed it with the liberty. For the liquid products, the guideline says that if the liquid products, they are stored in the semi-permeable containers and subjected to the water loss and exposure to the lower humidities. It is not like a closed container like your ampules, like that. It is having a corked bottles and screwed bottles. They are having a stability condition 25 degrees centigrade plus or minus to 40% RH, 30 degrees centigrade to 40% RH, 40 degrees centigrade, and you will be having a 75% RH is needed. It is actually a 75%, and it got a 15. I will correct it. So this is actually what is required for the liquid products. Also, high intensity light cabinet and the cycling chamber is capable of cycling both temperature and humidity are also needed sometimes for the photolysis testing, where you have got a UV light lamps and they will be sending the light of a desired wavelength to the product, whether they are photolytically degraded or not. We have already seen in the light they are causing the photons and making a degradation, so we need to control it. So these ovens will be having a capability to send the light also. That will also be used to the concept of the accelerated stability testing. When you have got real-time testing, like during your shelf life, you are going to test your stability. Why the this accelerated has come into the existence? I have already mentioned, when your shelf life is 2 years, you cannot wait for 2 years, and if your shelf life is 5 years, you need to wait till 5 years is coming, then only you can launch your product. People are and patients are waiting for the disease, and you are having a product, but you are not able to launch. For that purpose, what regulatory bodies they say, individually in every country, for a certain period of the time, if you give, nowadays it has been made to 6 months, the 6 months data of the stability, if you are proving that your product is stable, and your real-time data of 6 months, if you are supplying it, we will see the data and we will give the permission, you can enter into the market. Once you are launching after 6 months, you can study the long-term till your shelf life. That is, whether it is 2 years or 5 years, you keep on doing it without stopping, and you supply the data to us. If any problem is there during your journey of a batch, then you withdraw your product from the market, and you can sell your product, no problem, if it is not having any problem. If you find any problems during your real time, and you inform the product which is launched later onwards to get withdrawn from the market. This is actually what the importance of the accelerated stability testing. The studies are designed to increase the rate of chemical degradation and the physical changes of the drug product by using exaggerated conditions 15 degrees centigrade than what we are going to launch. with the purpose of monitoring the degradation. So be increasing, and we can predict in advance when the damage is coming. We can take the product from the market, and we can predict that it is also my product is stable. It means really they are going to work. You may be understanding now how you are having this much of journey is going on before you are launching your product. It means studies before entering into the patient's home and into the patient's hand. So to evaluate the impact of the short-term excursions and predicting the shelf-life under the normal storage conditions, this is a good methodology. We will conduct accelerated conditions shorter period of the time and predicting it in the long-term storage and predicting it by extrapolation. So the design of accelerated stability may include elevated temperature. Exaggeration means we are going to use little bit higher. So what that methods of the accelerated stepping is freeze thaw test. One is keeping in the deep freezer and keep higher temperatures. So this is actually called as a freeing and thawing test. If you are keeping in the room temperature without changes, it may present long keep out, that will degrade very fast. This is actually we have got a centrifuge that will cause the sedimentation and the creaming and cracking of an emulsion very faster than waiting for 2 years or 5 years. If you are centrifuging them, if they are cracking or if it is not able to crack and withstand the even centrifugal force also, it means that it will stay in longer period of the time without any problem. Another one is the shaking test. An artificial shaker machines are present. The shakers, it will simulate your temperature conditions and it will make the number of agitations. They cause the damage very faster than the regular one. And elevated temperature test, this is actually what is being done. You are going to do the practical where you are going to expose your solution into the higher temperatures. One major experiment you are going to have, that is 50, 60, 70, 80 like that. And you don't know the data for 25, but you can predict from this data what is the degradation hours or 48 for practical. If you are elevating your temperature, your practical can be completed in 3 hours, but you can get the data for the last longer period of the time. You need not wait, you can get the data. That is actually what the elevated temperature test is. So now they have given a general storage conditions and temperature and humidity control. For the long term is, there are whole world is divided into the 4 zones. So 25 plus or minus to 6. So we are going to have this, and there are certain zone countries when you are taking it, the temperature is a little bit higher than the room temperature of 25. So they are having a 30 and 35% RH. It means they have got a temperature little bit higher, humidity is lower. So it is required to be tested minimum of 6 months. And there is another one, that is in the coastal areas. So in the coastal areas, when you are present, this is temperature and the humidity is high. So the 30 plus or minus 2 and 60% is the temperature. This we are going to employ. And intermediate testing, when you are taking 25, we are going to have a 30 plus or minus 2 as a 6 months. For the accelerated testing, 40 degree centigrade and 75% RH. These are all GPAT questions, and you are going to bound to remember them and the zones and the temperature condition for the GPAT, because you are going to be asked in the competitive examinations. And the zone 1 and zone 2, what is the long-term storage condition with respect to temperature and humidity, and what is the time period which is allowed. So these are all the GPAT. Extension of learning, accelerated are mandatory. And you are going to do intermediate also as a packaging. You are going to keep one. Why you want to do when you are doing 25 and you are going to do 40 degrees centigrade, why are you doing intermediate 30? That we are already employing in 30 and in the previous case also in the long term. But here we are going to do 30 plus or minus to 60% RH. So if you are doing 25 and you are directly jumping into the 40, say for example, you are having a failure at the accelerated condition like a 40 in your stability testing. Then what will happen? You can use the intermediate data and you can tell that you don't increase the temperature beyond 30 by having this data. So we need to study intermediate also at 60% RH, that is fixed. For the zone 4, with the intermediate and long term both are same. That is the reason you will be having a long term studies and accelerated studies. For the remaining zones, you are having both, that is 1 to 3 zones. We have got long term, medium, that is intermediate and accelerated stability. For that purpose, what you are having? You are having 3 ovens. Each oven has got that particular which zone your product you want to sell. You need to follow the temperature and RH. And you need to store your product for at least 6 months. You withdraw the sample and study it and see that whether it is physical and chemically whether they are stable or not. And you supply the data. In the long term testing, any problem, you recall the product from back from the market to your factory. Otherwise, you keep your product selling, keep on selling it. This is the way you can enter into the market. If anybody wants to have studies, generally in the B.Pharmacy 4th year, you are going to have a project. There you are going to see these ovens, because in our college we have got an oven. We can set the temperature and the humidity, and you can store your product and study your stability for the desired period. Desired period of the time. Most of the time we should not switch off the ovens. They are keep on going and running, and we keep continuously without any skip and without switching off them, because when you are switching off them, it won't maintain those conditions. It will alter the storage condition. It will give the wrong data. Product packaged in the semi-permeable containers where it is not having like blisters and our ampoules. So like you have got a corked one which has been given long term and intermediate and accelerated. So previously what we have already seen for the zone 1 and 2, 25-40% RH, and long term 30 plus or minus 60% RH, and intermediate 30-60% RH. If it is the same, which is applicable, if you see critically here, in the zone 2, there is a variation of 35%. Here it is varying because it is a semi-permeable, so it is having an axis to in and out. So it is having increased to 60% RH in this particular case of semi-permeable containers. They are got having a environmental factors into the in. So such cases, depending upon what form in that condition. Product which is intended to be stored in the refrigerator. You may get the question, sir, I am having a COVID vaccine. So the COVID vaccine now we are suggesting to use it in the 2 to 8 degree temperatures. If you are asking me to use accelerated condition for this COVID vaccine, whether it is Covishield or a Covaxin, at 40 degrees centigrade within it will get degraded. So how can I know my shelf life? And how can I say that I am having an expiry date period for that? How can I study it? For most of the times, the refrigerated products, they are having a different condition for the testing of long term and your accelerated condition. So for COVID vaccine like 2 to 8 for Covishield and Covaxin, we know that during our initial pre-formulation studies, we know that they are required to be kept in the refrigerator. There is no other option. For that purpose, we need to have a conditions of your long term and accelerated, not like regular one, what you have seen for the regular 3 time like previous conditions. This one is 3, it means it is varying from the 2 to 8, in the range of 2 to 8 for 6 months temperature. That is under control conditions 23 to 27 degrees centigrade, 60% RH. So we are going to have in the long term condition, we did not have any this one effect. What that 60% RH is not there. Do remember it, because your refrigerator will not have capacity to maintain the relative humidity. Refrigerator is meant only for the temperature control, not for the air conditioning to the desired RH. We don't have dehumidification, humidification. We have got refrigerator only defrosting. And we want to maintain in the freezer, we have got a 2 to 8 refrigerator temperature, but we don't have any maintenance of a fridge for the maintenance of humidity. So this is actually not having any conditions of RH, but the accelerated condition, it has got control of humidity also. Why these are all we are breaking these heads and into the market? We are creating, say for example, I am entering into the desert region where the temperature is 30 and humidity is 35. I am entering into the coastal region where we have got a temperature is very high and humidity is also very high, 30, and we are going to have a 60-degree RH. So regularly, like country like Indian conditions, which you are 25 is temperature, and we have got 60% RH. We cannot take our product there. Only the thing is, what you can do, you can create the similar condition in your lab by purchasing an oven. That oven can maintain the condition of temperature and humidity and simulate into the particular country which is present in that zone. So that you can test it in your place of factory itself and get the idea of how the product is behaving, and then you can launch your product into that market. This is actually what important stability testing in your pharmaceutical industry examination. Previously, what you are going to do, all the research is like a sessional exams, but the stability is like a term and exam. All factory employees, they keep on waiting the data of stability. If they are getting successful for 6 months, then they do the parties, say that yes, we are going to entering into the market because we can earn the money. This is actually what the criticality of the stability studies. Now, what is the product intended for the storage for the deep freezer, which we need to put it in the deep freezer, which we are having it. So that is having a long-term stability concern. That storage condition is minus 20 degrees centigrade plus or minus 5, and 12 months data we need to supply, not the 6 months. Do remember in your deep freezer condition GPAT period for this deep freezer is not like 6 months; it is 12 months. And previously, what you have seen plus or minus 2 degree in case of 25 RH. If you see here, it is plus or minus 5 degree. That deviation is more liberal. It means you can alter from the 15 defrosting when you are making it, you may come down to lower. So that region is very high. Wherever you have got a little bit stringent. So you see, if you are having a 5, that deviation is plus or minus 3. This is also being asked. You need to memorize. There is no other option. How much is the time and the conditions? All these tables are given. So according to the guidelines, the ambient and beyond 12 months to cover the shelf life. It means 1 year extra we need to study in addition to your shelf life. It means if you are launching your product in the real time, so you are going to study 2 years your expiry date. You need to study long term with the expiry date of 5 years. So you need to conduct study of real time by keeping that package in the oven for 6 years in your lab. It means when you are manufacturing your product, you keep some bottles and samples in your lab in the factory for 6 years. If your expiry date is 5 years, and keep on observing in regular intervals and getting the data tested and supply the data to the regulatory body where you are launching your product in which country, and you are going to see that there is no harm to the patients. If you find during this testing any harm or changes which are going to cause the damage of the health of the people, then you can give the indication to all the distributors and regulatory body says that you get back the tablets and capsule from the market because it has got some error there, and I don't want to kill the persons there because it will affect my company's progress. Because the persons, when they are getting died after using this packaging, when the stability has already gone, you have found out in the lab. In the similar manner, it will happen in their country also. So what do? In advance, you recall the product and safeguard your country's your factory image, and making that as you are recalling that particular product, and you are safeguarding the health of the people, not allowing to get using of a degraded product, that is destabilized or decomposed product. This is actually what the effect of real-time studies, and you are extending 12 months to cover the self-love product. Intermediate storage condition data are required when sufficient changes occur in the completion of the study under the accelerated conditions. So if you are having some trouble and you have got finding a flaw and a problem in the accelerated condition, this intermediate stability is becoming as an accelerated condition, and you remove the accelerated condition, you don't follow them, and you prepare according to the intermediate condition. So the accelerated condition storage must be greater than 15 degrees centigrade above the ambient storage conditions. Most of the time, that is the recommendations. It will be greater than 15 accelerated condition. Then only it is called as accelerated or exaggerated condition. It means if you are putting your product in the 5 degrees, you are going to have a accelerated greater than 5 plus 15 means 20 as an accelerated temperature. This is actually what is recommended. So the testing frequency, how frequently you need to do it. Most of the times, for the long-term testing during the first year, you have done every 3 months you need to study. During the second year, you need to sampling every 6 months. Afterwards, you need to do it for sampling for years. So after 2 years, it is yearly, once in a year. It means you have got a shelf life of 3 years. So first year, what you do, every 3 months means 4 samples you will be analyzing every 3 months, 3 months, 3 months, 6 months, 9 months, 12 months. After that, you are going to do 1.5 years and 2 years. After the third year, only 1 sample. So you keep on taking the samples, and these samples are in your lab only, in your factory only, in the oven. They are kept under the 25 RH and 60% RH and 25 degrees centigrade. So you have sold the product. It is already being used by the patients. First, you are launching your product, but you are withdrawing according to the samples, and you are studying it and finding that any problem is there for the dissolution, hydrolysis, or it may be due to the changes with the oxidation, and any problem is there. So you are finding it. If no problem is there, you will be very happy. If problem is there, you will get back the product back. And accelerated testing done every at least 6 months we need to do. It is suggested that it is a sampling points are 0, 3, 6 months. Generally, we conduct 1 to 3 months also, because it will give a confidence that we have got a 0, that is initial sample, 1, 2, 3, 6 months. That is 6th month. So this should be done at least 6 months. But mandatory data we need to supply for 3rd month data and 6th month data to the regulatory bodies for the getting a approval. Approval means you can enter into the market by giving the data. Based on this particular one, we are seeing that we have got very importance of these conditions of the temperature into the stability is very high for the your stability is concerned. We are having a temperature effect. For that purpose, we are having so many approaches to study the effect of temperature on the drug product stability by having increasing the temperature, and we need to study them. So that is what we are going to study in the due course of time in the next class, how we are going to predict, and by studying at the higher temperature and bringing back to your room temperature and predict the conditions. Before that, we need to apply your kinetics, what we already learned initially before our summer vacation, that is 0 order kinetics, 1st order kinetics, and 2nd order kinetics. Or it is following pseudo 0 order or pseudo 1st order. And among these 5, which order is following my product? That's what first we need to determine. After determining that, store the product in the particular condition and apply this particular order kinetics to that particular data. That is initial concentration and final concentration at the particular time point, like 3 months, 6 months, 1 year, 1.5 years, like that. So after that, you are going to study the rate constant. Then we are having a off-life. Then we are calculating the shelf life, and we are predicting it remaining things by using the same data. this journey which is required to be followed to see that whether which product is following which type of order, that is the first order kinetics. In that, one component concentration is very important, and it is following the degradation based on that component. Zero order, it is not dependent on any concentration of any component present in the drug and excipient, just it is degrading by its own without any effect of any concentration present. In the second order, there are two concentrations are present in the reaction. Both are concentrations are required to progress. This is, we have already studied in the previous case, and we apply this particular data and we do the analysis to predict our accelerated condition into the room temperature and predict the expiration period, and we are going to give some expiration period rounding off to the nearest value, that is lesser than the value of whatever it is having the nearest years, and we launch the product. I hope you understand the concept now. So we will be having a that part we are going to study in the next class. This part we have already discussed it in the previous classes which are before summer vacation. I already mentioned. One is you have got the rate of kinetics, that is zero order, first order, second order, and pseudo orders. So depending upon how many exponent which is present, depending upon the order is decided. So the first one is zero order, it is independent of any concentration. And we have seen this equation, we need to memorize it, there is no other option. We have already completed this portion. And there is a calculation for the T off and your self life, that is a T90. That will be given C0 by Tk and 0.1 C0 by K. This one we are going to use it. This is actually what we are going to have. In the red box is the kinetic equation. C minus C0 is concentration at the time T, and initial concentration is equal to minus K into T. That is the T is equal to time. The time in our case is now is 3 months or 1 year, accordingly what time point we are taking the sample. Similarly, we have got a first order. So in the first order, it is dependent on one concentration of any one drug. The equation is this: log C is equal to log C0 minus Kt by 2.301 in the log with base 10. So the above one is the natural logs, and we are going to plot it, and we are going to predict. Your self life is 0.693 by K, that is rate constant, and that is off life, and shelf life is 0.015 by K. This is actually what the first order is. We have seen. Similarly, we have got pseudo order reactions where one concentration of one ingredient is very high, so it will appear as a zero order. Similarly, we have got a second order. It is dependent upon the two concentrations of the excipient, or it is a drug which is having involving the reaction. There we are going to have a kinetic equation: 1 by C is equal to 1 C0, 1 by C0 plus Kt. And your self life and off life is 1 by K into C0, and shelf life is 0.11 by K into C0. So these rate equations and equation for the off life and self life are very important for your GPAT. You are going to have in the GPAT. There you are going to see that what is the equation for the first order, zero order, first order, second order. What is the equation for the off life and self life? That is T off and T90 or T.9, which is given self life. You need to memorize these equations. If you keep all this knowledge is ready, we are going to enter into the prediction of our determining our what order we are going to follow and determining the self life. Before knowing this particular one, we need to determine another one is the substitution method. In the substitution method, what we do, we are going to put our data in the equation of rate constants, what we have done seen in the previous slides, and see that in every point it is appearing only. If it is varying and fluctuating, it means it is not following the order. That is actually what the substitution method is. By doing the concentration versus the time graph and predicting the K and K equation, it is giving constant in every time. Another one is the off-life method. The off-life of the particular point when you are using the order it will be same if you are putting in the half-life equation for all the time points. Then it is actually one. And the graphical method which is used when you are plotting a graph in the first order, it will be straight line. If it is a zero order, it is a straight line, or in the second order, straight line. Wherever the graph is straight line, it is following as that particular order. So once you are fixing that particular order, you need to follow that order kinetics equations only and calculate the self-life and half-life. Then we are going to enter into the calculation of expiry date and your accelerated stability testing. That is very, very important in the examinations in the second sessional also and your term also. And not only that, you are going to do this in your factory when you are getting a job. So this part we are going to study in the next class, and this accelerated stability and prediction of expiry date.